Pluto is an icy dwarf planet in the Kuiper belt, a ring of bodies beyond the orbit of Neptune. It was the first and the largest Kuiper belt object to be discovered. Pluto was discovered by Clyde Tombaugh in 18 February 1930 and declared to be the ninth planet from the Sun. So let's jump into the video to see, is Pluto a ocean planet? We publish good content videos every day. If you're not subscribed to the channel since, don't forget to tap the subscribe button below, otherwise I will notice you. What is Kuiper belt? The Kuiper belt is a donut-shaped ring of icy objects around the Sun, extending just beyond the orbit of Neptune from about 30 to 55 astronomical unit, believed to contain many comets, asteroids and other small bodies made largely of ice. It is far larger, 20 times as wide and 20 to 200 times as massive. Pluto has been home to a vast ocean for 4.5 billion years and had an underground ocean from the very beginning. Though Pluto is now famously frigid, it may have started off as a hot world that formed rapidly and violently. It lies beneath a frozen crust and could be harboring life. An analysis of images from NASA's New Horizons mission shows the dwarf planet was hot when it first formed. This would have created liquid water that has persisted to the present day. To put the discovery in perspective, Earth's seas are less than 4 billion years old. It has implications for the potential habitability of other icy worlds, which may also contain hidden oceans and perhaps aliens. Planetary scientist Carver Pearson said, even in this cold environment so far from the Sun, all these worlds might have formed fast and hot, with liquid oceans. This subsurface ocean developed long after Pluto formed, after ice melted due to heat from the radioactive elements in Pluto's core. It was previously thought Pluto began as a solid snowball and then began melting slowly over time due to radioactive decay. Pluto has had an ocean that has been slowly freezing for all of solar system history. Pretty sure water is one of the ingredients for life. Having that water around longer will allow it to react with the rocky core beneath, providing more chemicals to work with. The team at California University in Santa Cruz compared geological observations of the 2015 flyby with the thermal model simulations of Pluto's evolution. First author Mr. Pearson added, by examining Pluto's features, today we can begin to understand its birth 4.5 billion years ago. They range from 11,000 feet tall ice mountains to smooth plains and dunes made of methane sand. Water expands when it freezes and contracts when it melts. The topography of Pluto is dependent on whether it was hot or cold from the outset. If it started cold and the ice melted internally, Pluto would have contracted and which should see compression features on its surface. If it started hot, it should have expanded as the ocean froze and we should see extension features on the surface. We see lots of evidence of expansion, but we don't see any evidence of compression. So the observations are more consistent with Pluto starting with a liquid ocean. As Pluto was forming, new chunks of rocks and ice were crashing down. Each of these impacts is like an explosion that would warm the nearby region. If Pluto had formed slowly, the surface could have cooled off in between hits. Pluto formed fast, in less than 30,000 years. The ice got so warm it began to melt. After an initial period of gradual melting, the subsurface ocean would have refrozen. So compression would happen early on, followed by more recent extension. The older surface features on Pluto are harder to figure out, but it looks like there was both ancient and modern extension of the surface. The findings suggest other objects at the solar system's edge were once hot with oceans. Some could still be there today. Pluto and other large dwarf planets in the Kuiper belt such as Eris, Makemake and Haumea may have possessed subsurface oceans ever since they formed. This may have influenced the potential habitability of these distant icy worlds. At this point, we don't know the ingredients or recipe needed for life to emerge on any world. Still, we think liquid water is an important ingredient, and this work suggests Pluto has had that for a long time. For a long time, people have thought about the thermal evolution of Pluto and the ability of an ocean to survive to the present day. Now we have images of Pluto's surface from NASA's New Horizons mission. We can compare what we see with the predictions of different thermal evolution models. How Pluto was put together in the first place matters a lot for its thermal evolution. If it builds up too slowly, the hot material at the surface radiates energy into space. But if it builds up fast enough, the heat gets trapped inside. The idea of an underground ocean on Pluto first came about in 2016. Odd land formations across a region the size of Texas called Sputnik Planitia convinced NASA. But detecting organisms swimming around will be a challenge. It's covered by an ice shell that is likely over 100 km thick. Pluto was stripped of its status as a planet in 2006. It lies in the Kuiper Belt, a freezing ring of debris orbiting more than 4 billion miles from the Sun. Biosun did caution that New Horizons could only take high-resolution images of about half of Pluto's northern hemisphere. We can imagine that if we only looked at the geology of 1/4 of Earth's surface, but we would also be missing some context. For now, they can only work with what they have. It would take another spacecraft to go back and image the rest of the surface to really find out what they missed. So I think you guys enjoyed this video. Please make sure to click the like button below this video and subscribe to the channel.